Hello everyone. In this video, we're going to find the sum of this finite series here. So how do we find the sum of this series? Notice here that the first term, let's say 1 over square root of 1 plus square root of 3, can be written as, if we're going to rationalize the denominator. So we're going to multiply this denominator by its conjugate, that is square root of 1 minus square root of 3. Of course, we have to multiply the numerator as well by that conjugate. And we'll get here square root of 1 minus square root of 3 all over 1 minus 3. And the denominator negative 2 can be written as positive 2 by multiplying the denominator and the numerator by negative 1. And we'll get square root of 3 minus square root of 1 all over 2. So as we can see from here, this fraction here is just equal to square root of 3 and then minus square root of 1 all over 2. And in general, this fraction here, so each of these fractions here can be written as by rationalizing the denominator, so multiplying the denominator and numerator by the conjugate, and we'll get here square root of n plus 1 minus square root of n all over 2. Therefore, we can write our series into the following form. So this fraction here can be written as square root of 3 minus square root of 1 all over 2. This can be written as this fraction here, and so on. And this last fraction can be written as square root of 100 minus square root of 98 all over 2. And now it looks like our series is a telescoping series. So let's try to find the telescoping sum of this series. If we look at the first four terms of this series, we'll see that this square root of 3 here cancels with negative square root of 3, and this negative of square root of 4 cancels with the negative of the negative square root of 4. It seems that we still need to add more terms to figure out the sum of this series. And if we're going to include the next term, we have here plus square root of 7 minus square root of 5 all over 2. We see that this square root of 5 here cancels with this negative square root of 5. And we now see from this sum that this term here, this fraction, vanishes in the sum, which tells us that if we add 5 or more terms of this series, the remaining terms will be these two terms here and then these last two terms here. And if you still want to verify this pattern, then you can still look at the next term of our series. And you'll see again that that square root of 6 cancels with this square root of 6. And therefore, we have again these terms as remaining in our sum. And if we're going to list down all the terms of our series, then we know that this positive square root of 7, negative square root of 8, and so on up to this negative square root of 97 and square root of 98 will cancel out in the sum. Therefore, the sum of our series is equal to negative square root of 1 over 2, so that is negative 1 half, and then minus negative square root of 2 over 2, so that is positive square root of 2 over 2, and then plus square root of 99 over 2, and then minus square root of 100 over 2, which is equal to negative 10 over 2. And we can write this as a single fraction as square root of 2 and then plus this 99 here is just equal to 9 times 11. So square root of 99 is equal to 3 square root of 11. And then we have here minus 1 minus 10. So that is minus 11. So this is the sum of this finite series. I hope you enjoyed this video. Please don't forget to like, share, and subscribe to help me grow this channel. Thanks for watching, and I hope to see you next time. Bye bye.